In this video, we're going to talk about domestic freezers. Again, as with domestic refrigerators, we do want to talk about this as a unit. So we're going to cover a lot of the components you may already be familiar with, but now they're working together with one common goal. Okay, domestic freezers have several characteristics. It's a one temperature appliance. It is a low temperature refrigeration system. Domestic freezers take longer to freeze food than commercial systems, and the food must be packed correctly to properly freeze. The functions on a domestic freezer, it's to store food that was purchased frozen, and it's designed to freeze small amounts of food. And again, the key word is small amounts. It's not designed to be a commercial freezer system. The cabinet or box is made with a sheet metal exterior with a plastic interior. There are two types or styles. You have an upright version that takes up less space. It's usually located in the kitchen. Might also be in a garage. You have a chest type that is more efficient than upright units because the cold air stays in the box when the door is opened. So we have a vertical configuration and we have a chest configuration. The airflow inside the vertical refrigeration, when the door is open to either add or remove product, means that we allow warm air to fill the box. The heavier air falls out of the box because cold air is heavier than warm air. The airflow inside a commercial unit, when you open the top, the heavier, colder air stays in the chest-type freezer even when the lid is open. So, in a way, the chest type freezer is more efficient. The cabinet interiors can be metal or plastic. Walls are insulated with fiberglass or foam. Broken plastic needs to be repaired. Gaskets have to remain tight-fitting. Air leaks cause extra load on the compressor and will increase run time and therefore the power bill. Warm air can leak into the box if the door gaskets are defective. Again, gaskets are very important. The forced draft type evaporator uses a propeller or centrifugal fan. You can also have a plate type or tube type. No fan is used and it must be manually defrosted. You can have a freezer wall plate. Tubing is attached to the interior of the box walls. You have a freezer shelf design where the evaporator is actually in the shelves. Could be either open wire or could be a stamped plate. The compressor is rotary or reciprocating. It's usually located at the back of the unit on the bottom. Some units have a condensing unit on a slide-out tray. They're hermetically sealed, welded compressors. So when you look at the upright systems, they're usually right at the back on the bottom, okay? The chest freezers might have them on a slide-out tray. Airflow might be in on the side and it might slide out, okay? Here you might have a grate covering it or something covering it. Sometimes they actually put a fiberglass air filter in there as well to try to prevent buildup on the condensing coils. These do need to be cleaned regularly, just like any other refrigeration system. Okay, compressor compartment of a vertical freezer, condensing unit could be on a slide-out shelf. Home units will always have an air-cooled condenser. There's three types. A chimney type must have enough airflow across it. A hot wall type, condenser is located inside the walls. Forced draft type is usually used on automatic defrost units. The back of the freezer might have a natural draft condenser. Okay, you have to give this enough space for the unit to cool properly or that compressor is going to cost much more to run and you're going to have food issues. A hot wall condenser, the back of the unit can actually be butted up against a wall, but the sides have to be open for air circulation because the condenser runs through the interior of the side walls. The metering device is most often a cap tube. It's fastened to the suction line to provide liquid floodback protection and increase the subcooling. Sometimes it's inside the suction line, but that's less frequent. Okay, so we might have it wrapped around or just running along the suction line. It's usually soldered to the line with some sort of soldering. If it's run inside, you'll see where a small tube goes into a larger tube in the refrigeration system. This is not as frequent anymore. Okay, it's mostly this. And this is just a cross section. Again, cap tube is separated on the outside of the suction line. Suction gas, high temperature, high pressure refrigerant. The heat is exchanged through the walls of the cap tube and the suction line. Now this serves two purposes. One, we're cooling that high temperature, high pressure liquid refrigerant a little bit by removing heat. And the second thing we're doing is adding heat to the suction line, so if there's any little bits of liquid refrigerant left in here, it gets pulled out. Typical operating conditions for the evaporator: it must be cold enough to freeze ice cream hard. Usually when the box temperature is 0 degrees, the coil can be negative 18 degrees for plate type. That means at 2.2 inches of mercury for 134A, 1.3 psi G for R12, which isn't used much anymore. Might be a drop-in replacement now for R12 because R12 is out of production. Coil can be negative 11 degrees for a force type evaporator, or which is 1.2 psi G for 134A, and 4 psi G for R12. Those are just rules of thumb. But again, you're going to deal more with the temperatures initially because you cannot put gauges on these systems unless they've been serviced before. Condensers are air-cooled. They're natural or forced draft. The design ambient temperatures on these could be from 65 to 95 degrees. The condensing temperature runs 25 to 35 degrees higher than the ambient temperature. The compressor should be hot to the touch. Air-cooled compressors have fins. They should operate quietly, and they're usually mounted on rubber feet. Extra load on the compressor can be caused by gasket leaks or constant opening of the box. Freezers have a thermostat and a door switch. The wiring diagrams are fastened to the box. Small heaters prevent cabinet sweating. The automatic defrost are controls similar to a refrigerator. Compressor runtime can start defrost cycles, and electric heaters are a lot of times used for defrost. Okay, again, we have a similar wiring diagram. We have our mullion heater, which runs constantly. That's to prevent defrost buildup on the door openings. We have our defrost timer, and this is a cumulative run timer. The motor of the defrost does not run when the thermostat is not cooling. Evaporator fan does not run in defrost, and there's a defrost heater. This could also be a hot gas defrost. There could be a solenoid here instead of the heater. This is a forced draft evaporator. We have a fan that blows air through it, and most often pulls air through it. Electric strip heater is in contact with the evaporator coil. Fan turns off, heater energizes during the defrost. To service the freezer, basically the forced draft evaporator motors run whenever the compressor's on. Sometimes they shut off when the door switch is open. And they a lot of times use automatic defrost, either hot gas or electric. Okay, the forced draft motor should not run during the defrost cycle. So before you say a motor's bad, make sure you check for voltage. Okay, if you have voltage to the motor and the motor's not running, the motor's bad. But if you don't have voltage, go dig around deeper because it might be in defrost. Manual defrost is a much less efficient way of dealing with defrost. You have to empty the freezer, use a pan of hot water or blow dryer, heat gun. Don't use sharp objects on the evaporator coils to get rid of ice. You'll puncture them. To move the freezer, you have to remove the food. Okay, you cannot allow the food to stay in the freezer while you're moving or servicing it. Use caution when moving any heavy equipment. Wear a back brace if possible. Lift with your legs, not the back, and use a hand truck if available. Never lay a freezer on its side. That can cause damage to the freezer components. You have to worry about food here. You can't let frozen food defrost, okay? Because refreezing frozen food a lot of times causes health issues and concerns about bacteria buildup in the food. Some companies offer customers loaner freezers. If that's not possible, use dry ice. Products can be stored in boxes with protective layers between food and dry ice. 20 pounds of dry ice is used for every 5 cubic feet of capacity, of freezer capacity, for a 24-hour period. That's a magic number that you, if you service freezers, you want to remember. 20 pounds of dry ice, 5 cubic feet of freezer capacity, 24-hour period. So again, domestic freezers are relatively easy to service. Single temperature, evaporator fan, condenser fan. Okay, they're just like commercial equipment, except there's a lot of additional components in terms of defrost timers, where the lines are run. If there's ever a leak within the cabinet walls, this is the one point you want to say it might be easier to replace than repair.